you can put the origin anywhere, so I just say the ball starts here, and the initial velocity is this arrow. So it starts off with kind of a big velocity, and it accelerates, it speeds up. So my drawing only has room to put 2 arrows in there, and that's okay. We'll say it is accelerating. Okay, velocity and acceleration both point negative. Velocity and acceleration both point negative. Okay. I guess I put that on the wrong side. So over here on your description, we'll say that the ball is speeding up in the negative direction. And see, this one's a little bit of a challenging set here. This is going to have motion in both the y and the x direction. So I'm going to leave that up to you to kind of determine what would happen there. Move to this side. Okay, and what we want to do here is write both a description and compare. Okay, as well as draw a motion diagram. So let's start with our motion diagram. Start with a reference line. Okay, the ball is down here at the bottom. So there's the first ball. That's the origin, or where position equals 0. Okay, now we ask ourselves, do these arrows agree or disagree? These arrows disagree with each other. So we know that the ball is going to slow down as it heads up. It starts off with kind of a large initial velocity here. So maybe someone kicked it or threw it. Maybe it was a jump shot. And the arrows disagree. Acceleration is opposite the velocity, so it slows down. Okay, and we learned that what's going to eventually happen is it's going to come to a stop. Okay, and then once it reaches its highest point, it stops, it turns around. It comes back down. Okay, acceleration continues to point down. Okay, in this case, we could say that this acceleration is due to gravity. So this A value is because of the force of gravity. So we call that acceleration due to gravity. Okay, and we know now that actually that acceleration is equal to 9.8 meters per second squared. So we've studied that and also saw that in our lab. Okay, so you would do that same situation again here, but just compare them. Okay, what's the difference? This velocity looks like it's a little bit smaller, so my initial velocity would be less when I draw this motion diagram on the right. Okay, same situation here. Okay, just go ahead and compare them. Okay, in both cases they disagree, so they're both slow down. Okay, it looks like this one has a large initial velocity, but so does this one. Okay, this one has a smaller acceleration than this one. So in the last case we said that the acceleration was due to gravity. So we might ask ourselves, well, where is gravity greater than planet Earth on another planet? So maybe this is the acceleration due to gravity on the planet Jupiter. Okay, they have a greater acceleration there because that planet is more massive. Okay, so go ahead and again, draw your motion diagram. For these, we'll say that up is positive, so on and so forth. Okay. Okay, in 5, a ball is dropped off of a cliff. So I would go ahead and kind of draw a cliff like this. You've got some water down below, okay, and a ball is dropped off. Okay, you release a ball. This is just like what some of you have seen now in the video analysis that we did on Logger Pro. Go ahead and draw your motion diagram of that ball falling. We know it's going to speed up. It hits the water and splashes. Looks like I ran out of room. Okay, this will accelerate due to the force of gravity. Okay. In this case, it says that the ball is thrown off of a cliff downward with an initial velocity of 3. So that simply means that that initial velocity is going to be greater. So this velocity right here, the starting velocity is 3 meters per second. It's greater than the velocity that you started with here when you just let it go. Okay? Because when you just let it go, that initial velocity is 0. So in this case, 3 meters per second is equal to the velocity initial. In this case, 0 meters per second is the velocity initial. Okay? So this one will still accelerate. It'll still speed up due to the force of gravity. Just because you threw it doesn't mean that it has more acceleration on it. It just started faster, but it's still under the influence of gravity, and so gravity is the only force that will cause it to accelerate. Okay? And there's more to that drawing that you need to add. Okay? In this case, a ball is thrown upward. So this one's kind of interesting. We've seen this in class. Okay? In this case, it's thrown upward. So it starts by being thrown this way. Okay, we know it's going to slow down, come to a stop, turn around, and come back. So I'm going to let you finish that. Okay? Again, most of these problems I'm just getting started for you. Okay?